Greetings, folks. For Ag and Natural Resources Marketing, I'm David Ammon, and you're watching Renew, the show about the amazing students, faculty, and staff of the College of Forest Resources at Mississippi State University. Today, we're joined by Samadhi Navalagay. She is a graduate student in sustainable bioproducts, and we're very happy to have you here.
Thank you for
having
me.
Absolutely. Samadhi, first, can you tell us a little about yourself, where you're from, and what inspired your interest in environmental research?
I'm originally from Sri Lanka,
Awesome.
and I'm currently a second-year PhD student at Sustainable Bioproducts, working with Dr. Jilay Jang. I think my interest in this area started back when I was an undergrad in Sri Lanka.
Sure.
And I had the most amazing research mentor. His name is Dr. Ranmal Gunatilaka. He's an alumnus of Mississippi State himself.
Okay.
And I remember he taught us environmental chemistry, analytical chemistry, and initially I was just so interested in the whole process of doing research,
Sure.
asking the right scientific question, drafting manuscripts, addressing reviewer questions. So I was really interested by it. I really enjoyed the whole thing. I think that enthusiasm and drive is still what motivates me to do research now.
Sure,
Yeah.
that's awesome. Yeah. I understand your research focuses heavily on metal contamination in waterways.
Yes, that's right. Yeah.
Why is this issue such an important environmental and public health concern?
Heavy metal pollution is a huge global problem. Even today, there are millions of people who are exposed to unsafe, contaminated water. And the main reason is, the sources of these metal contamination is all around us.
Sure.
Industrial discharge, mining activities, agricultural runoff, all these processes release a lot of heavy metals to the environment.
Sure.
And the bad thing is, these heavy metals don't naturally degrade in the environment. They persist, they accumulate, and then eventually they become part of food chains and get inside our bodies.
Right.
And long-term exposure to even small concentrations of these heavy metals can lead to serious health problems like kidney disease, neurological diseases. And
Right.
children are especially vulnerable to these heavy metal ions because it can affect their development, brain health. So that's why it's really important to develop sustainable, affordable technologies for water treatment.
Sure, sure. Do you think research in the realm of the AI server farms that have been popping up all over the world and country currently, is that, I assume that's getting added to this?
Yes, definitely, yeah.
Right on. For viewers unfamiliar with your work, can you explain what biochar and non-scale zero-valent iron are and how they
Yes.
help remove heavy metals? from
Yes,
water?
absolutely. So biochar is a carbon-rich material that's produced from biomass, such as wood waste, agricultural waste, any type of feedstock that has, such as sewage waste even.
Gotcha.
And so what happens is this biomass is heated in an oxygen-free environment. And under these conditions, it develops a highly porous structure, kind of like a sponge, that can trap pollutants. So the other part, the nanoscale zero-valent ion, which is also called NZVI for short, they are highly reactive, small iron nanoparticles that are fantastic at converting toxic heavy metal ions into more safe forms. So in my work, what I do is I bring these two together. And the problem is these iron nanoparticles, even though they are great at removing heavy metals, you can't use it as it is because they're highly reactive, they're small, they tend to clump, they tend to aggregate. So what happens is we use biochar as a support that will help to disperse and spread these iron nanoparticles so that they stay active in water for longer.
It's fascinating stuff.
It does. And a very specific focus of my research is to find conditions that will optimize the synergy between these two materials.
Sure. Wow. That's fascinating. So yeah, as you were saying, your study combines biochar and NZVI.
NZVI, yes.
into a new material. And what makes this material innovative compared to traditional remediation methods?
Yeah. So traditional, like conventional water treatment methods are effective. They're very effective at removing heavy metals. But the problem is most of these methods, they're expensive to set up and maintain. And
gotcha.
it's very energy intensive. And also some of these techniques generate secondary waste that should also be cleaned up.
Sure.
So in my case, the NZVI biochar composite for one thing, it's environmentally friendly. It's relatively cost effective because we're using waste, right? Like wood waste
right.
and all that. So it's relatively cost effective, environmentally friendly, and also sometimes this composite has magnetic properties to it. So in some engineered systems, after we use this composite for water purification, we can pull it out using a magnet.
Wow,
So,
that's convenient.
Yes, that's convenient.
Convenient extraction for sure.
Yes, so and also because I'm combining two very powerful materials together, there are multiple mechanisms playing, multiple mechanisms working simultaneously to remove heavy metals from a system. So all these factors and many more make my composite, more novel and innovative and easy to use when it comes to.
That's awesome. That's awesome. Well, Samadhi, we're going to take a quick break.
Yes.
You guys, please don't go anywhere. We'll be right back.
Want a career as big as the outdoors? Want to have an impact on the environment? The College of Forest Resources at Mississippi State University delivers hands-on training, ensuring clean air and water, wildlife habitats, and a sustainable environment. Creating new wood products and retooling old ones for today and tomorrow. Find a career in whatever path you choose. Majors in forestry, natural resource and environmental conservation, sustainable bioproducts, wildlife, fisheries, and aquaculture. Want a career as big as the outdoors? Choose the College of Forest Resources at Mississippi State University.
Welcome back. We're here with Samadhi Navalagay. Samadhi, good to have you.
Yes, thank you.
Going back to what we were talking about before the break, how could this research eventually impact real-world water treatment systems or environmental cleanup efforts? Could this technology eventually be scaled for industrial or municipal wastewater treatment?
Yes, definitely. So I think there are, even now, there is research on, many researchers are trying to scale this work and use it in industrial systems, for example. A very specific example is permeable reactive barriers, to clean groundwater. So, it has a lot of challenges, this composite. I'm not going to lie, but right now there are a lot of efforts being made to scale up this technology and for it to be used in industrial and large-scale applications.
Right. So would it take a vast amount of resources to sort of revamp current landfills, for instance, the way they treat their wastewater?
Yes. If you want to do it in large scale, we will need a large amount of biochar because the yield is. You have to optimize the conditions so that you get the right yield of biochar, the right yield of the particular composite that we need. In lab scale, we work with like 30, 40 grams of the biochar, but in industrial scale, we need much more than that. So we need to find the right conditions that give the optimum yield and the best performance. So it's kind of like a balance.
Sure.
Yeah.
It sounds like you've mentioned some of the biggest challenges you researchers still face in developing affordable and efficient remediation technologies.
Yes.
Are there any others you haven't mentioned?
Yes. So a big challenge in this field, using this particular composite is real world water systems are much more complicated than what we work with in the laboratory. In the laboratory, we try to use one metal ion and try to optimize the conditions of the composite. But a real world water sample will have multiple ions, many coexisting ions acting together, and there's a lot of solid material as well. There are microorganisms. So we need to do a lot more experiments to see how a composite that we develop, like for example, the composite that I'm developing, will withstand all those environmental conditions to see for how long it will last. Can it be regenerated under these conditions? So all of that has to be, all of that will take a lot of research effort to, it will take, it takes a lot of
tremendous amount of years and years, I assume.
Yeah.
Ongoing. fascinating stuff you're doing. And speaking of how fascinating it is, you recently placed second in the regional 3-minute thesis competition after being named the Mississippi State Grand Champion in our graduate student competition. That's awesome. Can you tell me a little bit about this experience?
Thank you. It was a very rewarding experience. I mean, a few years back when I came here, I never thought that I'll be representing Mississippi State University at a regional level competition. So when I got the chance after I placed at the graduate school level competition, I felt so grateful. It was such a wonderful experience, and I have to say I'm very thankful to the graduate school and to the college for supporting me and helping me stand alongside all those wonderful graduate students who competed at the regional level.
Sure.
So it's a memory that I will cherish.
I'm sure.
Yes.
Finally, Samadhi, what does your future look like in your eyes, and what impact do you hope your research will have moving forward?
I want to continue doing research. I mean, I love research. So I want to continue research in this same field, developing sustainable materials and all that.
Sure.
So I mean, I don't have big dreams, but I really hope that one day I can contribute to impactful research that will help environmental protection and water purification.
Sure. Well, Samadhi, it's been a pleasure having you on the show today.
Thank you for having me.
Absolutely.
Thank you.
Thank you guys for tuning in to this edition of Renew. If you'd like to check out previous editions, you can find us at cfr.msstate.edu or on YouTube. We're CFR Vids. Also, if you go to our MS State website, you'll find the rest of our social media handles. Thanks a lot. Thanks for joining us. Have a good one.